Welcome to the channel, Professor Wilcox, where today we do Algebra 1, Section 4.4, Graphing Linear Inequalities. Well, welcome to Algebra 1. Good morning or good afternoon to you whenever it happens to be that you're watching this video. Today we are going to be doing Section 4.4, which is graphing inequalities in two variables. You should have a note sheet that looks just like this, and you can go ahead and take notes on the problems that we are going to be doing over the course of this lesson. So let's first get the learning target down here, which is very simple, and it is I can graph a linear inequality. Okay, it's a very nice chart here in the upper left-hand corner that would allow you to sort of remember what type of line we have, what type of shading we have on the graph. This chart must be memorized by the time we take the quiz and the test, so try to commit this to memory if you can. We're going to first start with a simple greater than symbol here, which is one of our inequalities that we're going to be using. And sort of in this column right here is going to tell you what the line is going to look like. So if you have a greater than symbol, that's going to be a dotted line that's going to go through our graph. So I like to just put a little dotted line there to remind us what it looks like. A lot of people call that line a dashed line, but those are the same. And we're also going to have a less than symbol, which also goes in that column. So if you have either one of these symbols, the line or the boundary line on your graph is going to be dotted. Likewise, if I have a greater than or equal to symbol, which has a line underneath it, that line is going to be solid. And so that's going to be all the way through the line like this. And if I have a less than or equal to symbol, it is also solid. So technically, if you have a line under the arrow, a line at the bottom of the inequality, that means that you're going to have a solid boundary line, which would include. That's a very important word. This is going to be solid, means that it's going to include those points that are on the line. Now, likewise, we have greater than and greater than in this second row, which is going to tell me where the shading is going to be. In this case, I'm going to shade. I'm actually going to physically color in the part that is above the line, above the boundary line, no matter what the line looks like. And likewise, if I have less than or equal to, that shading is going to be below the line, and so the shading is going to look something like this, okay? You may find this lesson to be very simple and easy and is just the introduction lesson to 4-5, which is graphing a system of inequalities in two variables. So let's practice a couple and see what we have here. In example 1, we have y is greater than 2x minus 3. I want you to always think of these lines also as y equals mx plus b form, just like we've done for the last several weeks, even a couple of months. And so y equals mx plus b is going to be in the same form, where my b value is -3. I'm going to start by going down 3 units and putting a point right there. Again, I want to think of my slope as my m value. M is the number that's in front of the x, in this case 2. I want you to think of that as 2 over 1. And so from this point, we're going to go up 2, right 1, put a point, up 2, right 1, put a point. Just do that a couple of times. And now what I do is I look at the symbol, which is greater than, and I look at my chart over here, and I see where we land. Well, greater than is here, which means two things. The line or the boundary line is going to be dotted, which means the point on the line will not be included. And I'm going to shade above that line. And so I'm just going to graph a nice little dotted line that kind of goes through the points, put arrows on the ends to indicate that it goes on to infinity. And my shading is greater than, the way that I think about it is that all of the y values, because y is up and down, that are greater than this line are going to be shaded in this direction. So I'm just going to shade everything above to indicate that it goes on forever. So there's example 1. Let's move to example 2. I have something like y is less than or equal to 3. Y is less than or equal to 3. Sort of a unique one where I don't have an x, and you may remember that when I have just y and just a number, we have a horizontal line. And so all horizontal lines that are in the form of y equals 3 just say that it's going to go through the y-axis at 3. So let's go up 3 units and put a point right here. And the slope of all horizontal lines is technically 0. And so we're just going to put a couple of points to the right 1. And so I have a horizontal line that goes through here. And this line is going to be solid, because if you notice, I have less than or equal to, which falls in this category. Okay, and so my solid line and shaded below. And so I'm just going to color everything below the line, and it's going to look something like this. Okay, 2 more examples, and we are all set. Let's do example 3. I'm going to sort of squeeze this in here. Give me 2x plus 3y is greater than negative 6. 2x plus 3y is greater than negative 6. Now, before we graph some of these, there may be some work that we have to do in order to graph it. In this case, you may be thinking, we got to get y by itself, in which case we do. And so let's get y by itself so that I can put it in y equals mx plus b form. In this case, I want to start by subtracting 2x from both sides like this. So that's going to be canceled. I take everything and bring it down. So the 3y is going to come down here like this. The symbol is going to stay the same. I'm going to bring that down. And I'm going to rewrite this as negative 2x minus 6. I'm going to put my variable first. And now let's continue getting y by itself by dividing by 3. I'm going to divide every term by 3, divide by 3 like this. And so we're going to cancel out the 3's. And I'm going to rewrite my equation as y is greater than, I'm going to write this as a fraction, negative 2/3, and then the x value. And negative 6 divided by 3 is negative 2. So that is what we are going to put on the graph. It's in y equals mx plus b form, and so we are all set. The b value is negative 2, so we're going to start off by going down 2 units and put a point. Okay, my slope is the number in front of the x, which is negative 2/3, and so we're going to go down 2 and right 3, because my slope is down 2 and right 3, down 2 and right 3, so there's my slope. Okay, we'll check the sign. We have a greater than from my chart is going to be here. And so that's going to be a dotted line and shaded above. So I need a dotted line that kind of goes through here. You're more than welcome to use rulers if you'd like to keep the line straight. It's your choice. And above the axis is going to be shaded everything above the line, which is going to look something like this. We are all set. Let's move on to the final example, example 4, and we're going to wrap this lesson up. We have my first my equation, which is going to be negative x minus 4y is greater than or equal to negative 8. Greater than or equal to negative 8. All right, let's get y by itself once again, just like we did in example 3, by starting to add x to both sides of the equation like this. So x minus x is canceled. I'm going to bring this down as negative 4y is greater than or equal to, and I'm going to write this as x minus 8, right? Because negative x plus 8, I can just rewrite and switch them around and put the x value first. Now to get y by itself, we're going to divide by negative 4, divide by negative 4, divide by negative 4. This is going to cancel. And the one thing that we have to mention in example 4, which we have learned in this class before, is that if you have an inequality and you divide or multiply by a negative, you must take the arrow and switch it around like this, right? So greater than or equal to becomes less than or equal to because I divided by a negative. And if you remember my example before, if I have something that says 6 is greater than 3, right? If I change the signs to both of these, I now have negative 6 and negative 3 because I divided by a negative 1. You notice that negative 6 is smaller than negative 3, and so my sign switches around. The same concept applies here, where if I divide by a negative, I have to switch the arrow around, and we're going to rewrite. Here I have an x divided by negative 4, which is probably written best as negative 1/4 x. Okay, and negative 8 divided by negative 4 is a positive 2. And so this one's all set and ready to go. And so we can put that on a graph using y equals mx plus b. Well, my b value is 2, so I'm going to go up 2 and put a point right here. My slope is negative 1/4. So from this point, I'm going to go down 1, right 4, put a point, down 1, right 4, put a point. I can go back up to my chart. I say I have less than or equal to, and less than or equal to is here, which is going to be a solid line, and I'm going to shade below. So I'm just going to draw a solid line through my 3 points, which is going to look something like this. And I'm just going to shade below all of the line, and we are going to go through here like that. Thank you very much for watching. I hope that was helpful for you, and let me know if you have any questions through Remind, email, or in room 312. Bye-bye.